All right, we're starting a new unit here. This is 10.00 for geometry. Oh, no, this new menu right here is new. Okay. We'll go with classic. Sorry. Okay. So geometry, we're doing radian measure. And we're going to talk about sectors today. All right, so first we're going to be converting between radians and degrees. And when you're talking about radians is another way of measuring an angle. So just like when you measure the temperature, you can measure it in Fahrenheit or degrees. You can measure an angle in radians or degrees. And just like you can measure something in inches or centimeters, we can measure it in radians or degrees. And you're going to talk a lot more about radians next year. So this is really just kind of an introduction into it. So how you're going to convert between radians and degrees, you're going to use the same proportion. Whether you're going from radians to degrees or degrees to radians. So we know that to convert between radians and degrees, that in 180 degrees, we know that's equal to pi radians. So that's not the proportion, but that's going to be why the proportion works. So we know that 180 degrees equals pi radians. So our proportion is pi over pi radians over 180 degrees equals your radians over degrees. So if you are given radians and looking for degrees, you would fill in whatever this number is up here, however many radians you have. If you are going from degrees to radians, then you would fill in the number of degrees and solve for the number of radians. So let's go through and do a couple of examples. So number one, first we're going to go convert pi over 4 from radians. There's no symbol to represent radians. It's just pi over 4. Degrees, we know we have that little open circle to do that. Now, for this one, we have a quick trick. So we're actually not going to use the proportion on this first one. And our quick trick, which is significantly faster, is that if you're given a pi when going from radians to degrees, all you need to do is sub in your 180 degrees for pi, because we just said before that pi radians is equal to 180 degrees. So we can just take out this pi right here and substitute in 180. So I can take 180 divided by 4, which gives me 45. Now it only works if there's a pi in it and if you're going from radians to degrees. Otherwise, you'd have to use the proportion. So I'll show you number 2, what I mean by that. So this one, convert 3.5 radians to degrees. Okay, so this one, there's no pi in it. It's just 3.5. So now we have to use the proportion. All right, let's switch colors. So my proportion is pi over 180 equals radians over degrees. Now radians is always across from the pi. Degrees is always across from 180 because that's in degrees. So I'm given 3.5 radians, so I want to put that on the top across from the pi. And I'm solving for how many degrees, so I'm going to call that x. Once I have my proportion set up, I'm just going to cross multiply and solve for x. So here I have pi times x. I'm going to go this direction. Pi x. And then you're just going to do 180 times 3.5. Gives us 630. To solve for x, you're going to divide both sides by pi. So now I have x equals 630 over pi, and that is in degrees. So 3.5 radians is the same as 630 over pi degrees. That's an exact value. So if the problem doesn't say to round, or if it says leave your answer in terms of pi, that's how you should write your answer. If the problem says round to the nearest tenth or hundredth or round it all, you're going to want to put this in your calculator. So here's where it can sometimes get a little confusing because we just said pi radians is equal to 180 degrees. So in number one, you could sub in 180 in for pi. Here, we cannot sub in 180 degrees in for pi because we're not in radians here. We're already in degrees. So we're not saying that pi radians is equal to 180 degrees. This is just pi. So to put this in your calculator, you're going to do 630 divided by the pi key, not 180 degrees. So now go to your calculator, and because I want a decimal, I might not use the alpha y equals key because I'll show you what happens when we do that. So 630, and then over the pi key, that's second caret. I like to call that the food key. Pies and carrots all on one key. And we get that decimal, and you can write it out. On the newer calculators, on the colored ones, sometimes they give you back a fraction of it. Since it has a pi, this one gives you a decimal. But you could also type it in like this and get the same thing. All right, so then you would write out your full decimal. And that's degrees. So that's a little bit easier for us to imagine where that would be, how big of an angle that would be. So that's an approximate value because that decimal continues. We're just not seeing it all, where the other one is an exact. So it really depends on what the question, how the question asks you to give your answer for you to decide which one you want to give. All right, number 3. Now we're going to convert from degrees to radians. So convert 90 degrees to radians. Whenever you're converting degrees to radians, that's when you're going to use your proportion. So we're going to do pi over 180, same exact proportion. This time I'm looking for the number of radians, so I'm going to call that x, and 90 degrees goes across from my 180 degrees. Again, we're going to cross multiply, so I get 90 times pi equals 180 times x. To solve for x, I'm going to divide by 180. Now for these ones, you want to make sure you reduce. Now you guys, a lot of you can probably do this part in your head, but in case there's ones that you can't do in your head, I want to show you how to use your calculator. So when you type it in your calculator, really important that you do not type in the pi key to reduce it. So I'm going to put in my alpha y equals, and then I'm going to do 90 over 180. And like I was saying before, when you put it in as using alpha y equals, it'll give it back to you as a fraction. Where if I had written it like this, it's going to give me 0.5 instead. So to switch that to a fraction, because you want to make sure your answer is a fraction, you're going to hit the math key and then frac. And hopefully you guys have done that before. So either way is fine in your calculator. You should know how to do both. And now we're going to reduce it. So we know that's 1 over 2, but then I also have to bring this pi along. So that's 1 times pi, which is just pi over 2 equals our x. So pi over 2 is equal to 90 degrees. Now that should make sense to you because we just said pi radians is equal to 180 degrees. So if I were to convert this pi over 2 back to degrees, it has a pi in it, so I could just sub in 180. 180 divided by 2 is 90. So pi over 2 radians is equal to 90 degrees. This time convert 30 degrees to radians. Okay, so pause the video here and set up your proportion, reduce, and solve. All right, so you should have pi over 180. We're solving for radians, so that's x over 30. Cross multiply, we get 30 times pi equals 180 times x. Divide both sides by 180. And this time in your calculator, you would type in 30 divided by 180, reduce that fraction, which is 1/6. So your answer would be 1 times pi, which is pi over 6. So I want these written in terms of pi, so don't type the pi in the calculator, and, whoops, for some reason it never scrolls on here. So pi over 6, I want it as a fraction reduced and in terms of pi. All right, let's do one more. Convert 38 degrees to radians. Pause your video, and remember, give your answer in terms of pi and as a fraction. All right, so for that one, your final answer should be 19 pi over 90. So you should have done your pi over 180 equals x over 38. And one more of converting, this one a little different. This time, I want you to convert 3 pi over 9 to degrees. Pause your video, convert that to degrees. All right, so there's really two ways of doing this. One is go straight to, actually 3 ways, subbing in your 180 since we're going from radians to degrees and there's a pi in it. And then you would get your 540 over 90, which is 60. Another way, you could have seen that you could reduce this right away and then said that's pi over 3. And then subbed in your 180. Or you can cross multiply in the proportion, but that way is a lot harder to do. It just gets a little bit cumbersome with all the fractions. All right, so that's really it for converting between radians and degrees. Now we're going to talk next about sectors. So what a sector is if you have a circle and it's like a piece of the pie. So like this in here, that would be a sector. It's a piece of pie out of your whole circle. And what we're going to talk about next is how to find the arc length, which arc length is where this hits the circumference of your circle. The arc length would be this part of the circumference right here. And then we're also going to talk about the area of the sector, which is that shaded region that I just shaded in. So for our formulas, you need to know that S is going to stand for arc length. R stands for your radius. And theta is going to be your central angle. Now, what a central angle is it just means that its vertex is at the center of the circle. Center, central. So a central angle. Now, the part that's really important about these that you have to remember is that angle must be in radians for the formulas that we're going to use. There are other ways of doing this, but we're going to use these formulas because those are the ones that usually use next year when we do these. And we're going to practice doing those. All right, so your two formulas are, one is your area of a sector is 1/2 r squared theta. And your arc length is S equals r theta. Okay, so A is area of your sector. All right, so those are our two formulas. Big thing here to remember again is that theta must be in radians. That's in both of them. So if it's not given in radians, we need to convert it. All right, so this is number 7. So for this one, I want you to find the arc length and area of a sector. With a radius of 3 feet and the central angle theta is equal to pi over 18 radians. And let's find the exact values for them. So exact value means in terms of pi. And to the nearest hundredth. Okay, so first let's start with our arc length. So our formula for arc length is S equals R theta. So the arc length is the radius times theta in radians. So here I would just do S equals my radius, which is 3 feet, times my theta, which is pi over 18. So 3 times pi over 18, it's already in radians. I could put this 3 over 1. We do not cross multiply because there's not an equal sign in between here. It's multiplication. So you can cross reduce the 3 and the 18 or multiply straight across the top, straight across the bottom. So I'm going to cross reduce on this one. 3 goes into 3 once and into 18 6 times. So the exact arc length would be pi over 6. And this is length, so this is feet. That's exact. Now let's talk about the approximate value. So for the approximate value, should we sub in 180 in for pi or the pi key is the question. And the answer is the pi key because we're not converting from radians to degrees. So we're going to type in the pi key divided by 6 in our calculator. So go to your calculator, type that in. So pi key divided by 6. Or you could use the alpha y equals button here. Write out your full decimal. And then, I'll let you guys do that, and then round to the nearest hundredth. So to the nearest hundredth, it should be 0.52. Okay, so that is your approximate value for your arc length, and this is your exact value for your arc length. Okay, now let's talk about the area of that sector. So our formula for the area of a sector also has to be memorized, 1/2 r squared theta. So again, we just need the radius and theta must be in radians. And in this case, we were given that already in radians. So all we have to do is substitute in. So the radius is 3 squared. Our theta is pi over 18. These are all being multiplied together. So let's just simplify. So I've got 1/2. Since everything else is a fraction, I'm going to write this 3 squared is 9 over 1. And again, you can cross reduce here. So 9 goes into 18 twice. Or if you want, since I cross reduced last time, I'll show you how to just multiply across the top. 1 times 9 times pi is 9 pi over your 2 times 18. And then you're going to cross reduce from there. Or sorry, not cross reduce, but just reduce your fraction. So we've got our 9 over 36, and 9 goes into 36 4 times. So that would be pi over 4. And this is in feet and it's area, so it would be feet squared. So that is your exact value. Again, you can, if it asks for exact, you'd give it that way, or you could have cross-reduced here if you wanted to. 9 goes into 18 twice, and then you'd have pi over 4 right off the bat. And then we want the approximate value, so we type in the pi key divided by 4 into your calculator. Go ahead, pause the video, type that in right now, write out your full decimal, and then round to the nearest hundredth. And your nearest hundredth should be 0.79 feet squared. And that's your approximate value. So that's a rounded value. All right. Now we're on to number 8. Given the radius is 12 inches and theta equals 90 degrees, find the arc length and area of the sector. So first, let's start with arc length. Pause the video, write out your formula. So your formula should be S equals R theta. Now, again, with these formulas, we know R, but theta must be in radians. So now we need to convert that into radians in order before we can put it in for theta. So number one, convert 90 degrees to radians. So pause your video, set up your proportion, and convert that. All right, so you should have had pi over 180, and this one we actually already did, but good practice to do it again on your own. X over 90, and you should have ended up with pi over 2. All right, so now let's go back over here to our arc length. So now S is our arc length, our radius is 12, and theta is pi over 2. Again, we're multiplying, so we either cross reduce or we multiply straight across the top and straight across the bottom. So option 1, you could get 12 pi over 2, or you could cross reduce. 2 goes into itself once and into 12 6 times. And 6 pi over 1 is just 6 pi. So that would be 6 pi inches. This is in terms of pi, or the exact value. Now in this question, it did not say to round at all. So if it doesn't say to round, I want you to leave it as an exact value. Okay, and then let's find 3, the area. Pause your video, write out your area formula, and then substitute in. So again, this is what you guys should be using for theta, not the 90. So our area formula is 1/2 r squared theta. And now it's just a matter of substituting in. So we've got 12 squared for our radius, and theta is going to be pi over 2. Again, if you want to put that 12 squared over 1, you can. So here I've got 1/2 times 144 over 1 times pi over 2. So this one, instead of cross reducing, I'll just practice multiplying straight across the top, which would be 144 pi over 2 times 1 times 2, which is 4. And then we want to reduce that, which would give us 36 pi. And this is area, so it's going to be inches squared. Okay, I think I can fit this one in here. Number 9. If the arc length is 6 centimeters and the central angle is 1.5 radians, find the radius. All right. So we know that the arc length is 6 centimeters. So we call that S. We know the central angle is 1.5 radians. We call that theta. And we're trying to find R. So pause the video and write down what formula could we possibly use here? What formula has these variables in it? And hopefully you wrote down S equals R theta. Now we're going to substitute in what we know. So we know that the arc length is 6, so I put in 6 in for S. I don't know the radius, but I do know theta is 1.5, so I'm going to put 1.5 in for theta. I just use commutative property and switch those around, so my variable came second. And now I'm going to solve for R. So pause your video and solve for R. All right, so you should have divided both sides by 1.5, leaving you with the radius is 4, and that would be in centimeters, 4 centimeters. Number 10, if the arc length of a sector, so again, that arc length means it's this piece along your circumference, is 30 centimeters, and the radius is 10 centimeters, find the measure of the central angle in radians. Actually, I want you to find it in radians and degrees. Pause your video and see if you can do that on your own. All right, so we know the arc length is 30 centimeters. So arc length is S, radius is 10 centimeters, that's our R. Find the measure of the central angle theta. So I'm looking for theta. So you should have used that formula again, S equals R theta. So S is 30 centimeters, my radius is 10, and I'm solving for theta. So now to solve for theta, you would just divide both sides by 10. And notice here your units would divide out because that's 30 centimeters over 10 centimeters would give us theta equals 3. Because this formula is used only in radians, when you find theta, your answer is in radians. So now I found theta to be in 3 radians. Now go ahead and convert that to degrees. So since we're going from radians to degrees, if it had a pi in it, I could have subbed in 180 degrees, but it does not. So I need to put the 3, since it's radians, across from the pi and solve for x. So pause your video here and cross multiply to find out what this would be in degrees. And we'll leave, since it doesn't say it around, we'll leave it as an exact value. All right, so you should have gotten x equals 540 divided by pi degrees. And again, if you wanted to know what that would be approximately, you would do 540 divided by the pi key, which would be about 171.887. So this is theta also in degrees. All right, and the last one here, if the arc length is 8 meters and the central angle is 60 degrees, find the area of the sector, and let's leave our answer in terms of pi. In terms of pi. All right, pause your video and see what you can do on your own for this one first. All right, so hopefully you found this was your arc length, so that's going to be your S. This is going to be our theta, but we need to change it to radians for theta. And we're looking for the area of a sector. So area of a sector formula is 1/2 r squared theta. So in order to figure out the area, I need the radius and I need theta. Right now, I don't know the radius, I only know theta. So what else am I given that could help me to find the radius? And the only other thing we are given is our arc length. So we know the arc length formula is S equals R theta. So if we know S and we know we can find theta, then we should be able to find R. All right, so before we can do anything though, we need to convert 60 degrees to radians. All right, so first thing, convert 60 degrees to radians. Pause your video now, convert that to radians. All right, so you should have had 60 over 180 should have reduced to pi over 3. So your theta is now equal to pi over 3 radians, and that's what we should be using now for theta. And we're looking for the radius. So now, step 2, we're going to go to this arc length formula. Let's sub in our S is 8, and we know our theta is pi over 3 times our radius. Now let's solve for r. So to get r by itself, I want to get rid of this pi over 3. To get rid of a fraction, I know a lot of you are tempted to divide by pi over 3, but you want to make sure at this point in your math careers, you're multiplying by the reciprocal. Whenever you're tempted to divide by a fraction, multiply by the reciprocal, because we never want to leave fractions inside of fractions. So now these cancel out over here, and over here we'll get 8 times 3 would give us 24 over pi. So that's going to equal r. So now I have my radius and theta. So now I'm going to go back to that area formula and substitute everything in, but still a little tricky because we want to leave it in terms of pi. So my radius is 24 over pi, and that is all squared. And my theta is pi over 3. So a lot of pi is going on here. So it definitely can get a little confusing. So let's try to keep it straightforward and go step by step. So first I'm going to square the 24 to get rid of these parentheses. And then I have to square the pi as well. So I'll have pi squared in the denominator and leave my 1/2 and my pi over 3 as is for now. Now I would try to cross reduce. So we've got pi squared over here and pi. You also could try to, you could either multiply straight across the top, or you can cross reduce here with your 2 goes into 1, 576. It goes in 288 times. And then you can do 3 goes into itself once and into 288 96 times. And there's 1 pi on the top and 2 pi's on the bottom, pi squared. So pi over pi squared would leave you with just a pi. So now I'm left with 96 on the top over pi on the bottom. Or this one may have been easier for you to see if we multiplied straight across. So 576 pi over 6 pi squared, and then reduced your 576 over 6 to get 96, and then simplified your pi over pi squared. That's like saying x over x squared to get just a pi in the denominator. So that'd be 96 over pi, and that was meters. This is area, so it should be meters squared. So a lot going on in that last problem because you had to convert and then also use the arc length to find the area of the sector. But that is it for today. Please let me know if you have any questions at all. I hope you guys have a great day, and pi out.